Hello everyone, my name is Bernard Rodrigue and I am Director Wise Experience at Audiokinetic. I started working at Audiokinetic in 2005 and I've been involved with different projects such as the interactive music, the profiler, and in general user interface and wise authoring. More recently I've been involved with WAAPI, which we will talk more today. But first, let me introduce you Andrew Costa.
Thanks, Bernard. Hi, everyone. Andrew here. I'll be with you in the second half of this presentation where we take an in-depth look into ReaWwise, the integration we've built between Reaper and Wise. First, a little bit about me. I've been working as a software developer in the audio industry for about 8 years now. I've spent the last 1.5 of those years at Audiokinetic working on ReaWwise and the Wise VST plugins. I hope you enjoy this presentation. Back to you, Bernard.
All right. So today we'll be talking about connecting tools for game development. Wise connects to different tools, and today we'll talk mostly about Wise connecting to scripts, or scripts connecting to Wise, and also Reaper connecting to Wise. But Wise is also connecting to Unity and Unreal, for example, but that won't be part of today's presentation. Before we go further in the presentation, let's introduce a bit Wise for those that don't know what it is. So Wise is a complete interactive audio solution. On one part, there's a super optimized sound engine which runs on mobile platforms, on game consoles and PC, Linux, Macs. And on another part, there's a complete authoring application in which the sound designers, for example, can design their entire project. They can mix while connected to the game. They can profile what's happening, and so on. So let's dig inside Wise and see a bit how projects can be configured for a game. So what we have here is a Wise project made for a robot game, or a game with robots. And what we have here is a series of containers and sounds that describes what is the behavior for movement of a robot. So here we have a couple sound objects. So the sound objects can be played and they are attached to a WAV file. Also, what we have here is a random container. So the random container is going to play one of the children randomly. It is common usage for a game to use random container to reduce repetition of sound. So in this case, we have 6 different variations on the same sound. And then we have actually 4 random containers, which are inside what we call a blend container. So the blend container is a container that plays multiple children at the same time. So in this case, it's going to play 4 different layers for our sound at the same time. And on top of everything, we have a switch container. So the switch container is able to select one of the children at runtime, depending on the game variable set by the game. In this case, it's going to pick one of the blend container here, depending on if the movement of the robot is fast or slow, or is it a small piece, a medium piece, or a large piece of the robot that is moving. All right, now let's take a look at what is WAAPI and how it can be used to connect to Wise. So WAAPI is an inter-process communication system. It allows for client applications to connect to Wise and do remote procedure calls, for example. any application that has access to WebSockets or HTTP can use WAAPI. And so there's the RPC system that allows to call functions, but there's also a subscribe, unsubscribe system that allows for applications to be notified when something happened on a certain topic. So many things can be done in WAAPI. For example, retrieving objects from the project, modifying objects from the project, importing a new audio file, converting audio file, generating sound banks, and more. Also at the higher level, it is possible to open views, get selection, and also at a lower level, for example, playing sounds and do things that a game would normally do. So now let's take a look at a Python script that connects to Wise. All right, so we're now in VS Code, and we will try to run a Python script that does a WAAPI call. So this actual sample is taken from the Audiokinetic website. It's in this WAAPI Python examples. So what it does, it connects to Wise first, and then does a call to WAAPI using the function called getInfo, and then prints the results. And we see we have also Wise open on the side. So let's try to run the script and see what's the output. So we see it connected to Wise, and what we got is a JSON object that tells us more about the running instance of Wise. So we have the version, also the process ID, and a couple more things. So let's try to do something more complex, something more interesting also. So instead of calling getInfo, we will try to modify one of the objects that we have in our project. So if you recall, we had a robot structure here, so it can play robot movement sounds. So let's try to modify the volume for our object here. So the first thing we will do is first change the function to set property. Set property, it needs some arguments. So let's specify arguments here, and let's define those arguments right here. So the first thing we need to specify in the arguments is which object we will be setting the property. So to do that, let's hold the Shift key and right click the switch container here, and we'll be using copy path to clipboard, and then we paste it over here. And let's double those backslash character because we are in a Python string. Okay, so that's our object. Now, if we want to set the volume, well, we need to say which property we want to set. In this case, it's the volume. And the last thing we need to specify is the value of the property we want to set. So in this case, let's say we could say -10. So when I'm going to run this script, we will see the volume here go to -10. So let's try. Oh, it's not working. Why? Maybe I did something wrong. Oh, yes. So what I did is I have the wrong function name. I forgot to have the keyword object here. So the error here is telling me procedure URI is unknown, which is good. So let's fix that. So let's run again our script. And it works. So we see here the volume is now -10. So we could try -18. Try again. So now it's at 18. It works. So you see we have error handling in WAAPI. And if I was, for example, also to pass a string to the volume and say hello instead of -18 and run this, we're going to get an error value value type does not match the properties type. It's expecting a real 44 for the property called volume, and we got hello. So how is this working? So let's talk a bit about the architecture of WAAPI. So what we know so far, we have objects in Wise, and those objects have properties. For example, volume is a property, pitch, low pass, high pass, all those are properties, and they can be set through this function. So there's a generic object model with properties. Then let's bring the documentation of the set property in here, just to see a bit what's about the arguments. So this documentation from our website, we see object, property, and value. But we also see there's a schema here. So let's take a look at the schema. So the schema is a JSON schema which defines the structure of the JSON object for the argument. It can get messy, but if we look here, we have property and also we see value here. So property is expected to be a string, for example. It needs to match a pattern. And what we see here, it has also a description. So this same thing for the value. It has a description, and it says it needs to be either a null object, a string, a number, or Boolean. So if we go back to our page, the description that we saw in the schema are actually used to generate the documentation. So this really helps us having a complete and absolute documentation for any function in WAAPI. Along with the error handling, it really helps for the user experience when programming with WAAPI. So that's for the WAAPI example. Okay, so let's talk about WAQL. WAQL stands for Wise Authoring Query Language. So it's a language that is used to query the Wise project. And here we have the WAQL Playground, which is a web page that is using WAAPI to connect to Wise and allows us to query the entire project and know more about what's inside the project. So let's try to query with something very simple. For example, let's ask all the sounds in the project. So from type sound is going to return us all the sounds in the project. So at the moment we have 144 sounds, and those correspond to the sounds we have under our containers here. So let's try to filter down these sounds, because maybe there's a sound somewhere that has a volume that is not 0. So first, let's add the volume as a column in the query so we can see the volume here. So most are 0, but let's filter using the where query. So now we filter down the sound object to only 3 sounds which have a volume less than 0. So the where keyword can be used to filter out objects. So let's try something different now. Let's, instead of starting with the list of all sounds, for example, let's start with this switch container here. So we'll hold the shift key, right click, copy Wako to clipboard. I'm going to paste this query over here. So this returns us one object, which is exactly the object we requested in the path here. So let's try to obtain something else from this object. For instance, the children. So select children. It's going to return us all the children of this object. And we have 6 children here, which is the result that we have. Let's try something different now. So we are going to ask all the descendants. So descendants. So now we have 318 objects, which is the whole structure here we have. but maybe we're only interested into the random containers. Okay, so let's filter down this where type contains random. Okay, so now we have our random containers that are inside our switch container. So WAQL is an interesting system where when we have large projects, for example, projects with thousands and thousands of sounds, WAQL can be useful to query the project and know more about what's happening, to troubleshoot, or even for organization. Okay, so now what we see here is Reaper, and we have a project open. And this project is one of the Reaper projects included in the free Strata library that can be downloaded from the website. And this project is about robot movements. And people are very often starting to design sound in a DAW before it reaches Wwise. So this is a good example where we have a complex project set up with a lot of regions and a lot of tracks. So in this case, this project is set up so the regions are about variations on the same sounds, and we have also clusters of regions. So this area here is more about the slow medium robot movement, and this one is about slow large, and so on. And there's a couple tracks that defines also how the different layers of our sound are defined. So what sound designers normally do, they would use Reaper to render the files. In this case, the project has been set up to export 144 files at the same time. So if I render everything here, it's going to output the files in a folder, and those files could be used then and dragged to Wwise. And then what we would need to do is, well, we would get all the files flat in the default work unit, and we would have to organize them into containers like switch containers, blend containers, and random containers. And for this structure that we saw earlier, there's about 30 containers. So organizing 144 files into 30 containers could be tedious because we need to name everything and drag and drop. So a lot of clicks to get there. So what I'm going to do instead, let's delete this structure, and let's bring up ReaWwise. So ReaWwise is a Reaper extension that is able to connect to Wwise and take what's in the Reaper project and bring it to Wwise. So it's working along with the rendered file of Reaper. So for each rendered file of Reaper, it's going to try to set the correct values for the different container structure defined here. So Reaper as a system in the render settings that use wildcards. So the wildcards are like variables that resolve to a value that is that could be different for each file. So we're using the same wildcard system to define our objects here. And what we have at the bottom is a preview of all the structure and sounds and containers that will be created. So let's try to run this and import. I'm going to overwrite the last import, render the files, and then click close. And then as you see here, we have a new container that just was created, and it's exactly what we need. All the 144 sounds are now organized in the Wwise project. It took us about 4 seconds to create 30 containers, import 144 sounds, Yeah, so it really improves the workflow, and under the hood it's using WAAPI like we saw earlier.
Thanks for the demo, Bernard. It was great. Alright, so by a show of hands, who here in the room is a Reaper user? The presentation was pre-recorded, so I actually can't see how many of you put your hand up, but my hope is that a few of you did. Anyone who's connected to the talk virtually, please drop us a message in the chat. We'd love to know if you're a Reaper user. Alright, so why did we build a Reaper extension? Well, it turns out that Reaper is really popular in the game sound world. In 2019, Audiokinetic held a survey internally with our clients. We asked sound designers what their preferred DAW was. A resounding 50% said it was Reaper. That was a little surprising to us. We'd expect to see a bigger name at the top of that list, such as Pro Tools, for example. But why Reaper? Is it because it's inexpensive? I don't think so. Sound designers at both big and small game studios reported Reaper as their DAW of choice. We can probably rule out Reaper's marketing effort. I'm actually not sure if there is any, to be honest. So we dug a little deeper. After holding interviews with sound designers, it became quite clear it was due to Reaper's extensibility. Every time sound designers gave us a peek into their workflows, it always involved one or more extensions and or scripts. See, most DAWs aren't tailored for game sound design. They're best suited for linear workflows such as in music and in film. Now, this isn't necessarily different for Reaper outside of the box, but it's so extensible that the community is able to fill in those gaps by providing the missing functionality through these scripts and extensions. At the time of this recording, there are close to 2,000 scripts and extensions listed in ReaPack, which is Reaper's de facto extension and script manager. You want to set a track color automatically based on the track's name. There's an extension for that. You want to manage UCS naming for your tracks and audio files. There's an extension for that. You want to flash subliminal messages to your screen at a random time interval. There's actually an extension for that, although I'm not sure what its purpose is. So how does Reaper get all this to work? How is Reaper extensible? Well, it's through something called the ReaScript API. It's basically a collection of 500 functions that Reaper exposes. You want to have access to certain project and session information. There are functions for that. You want to manipulate, reorder, insert, and remove tracks. There are functions for that. You want to get region and marker information. There's functions for that. We also could tap into Reaper's rendering engine and trigger renders. On top of that, we could even manipulate Reaper's GUI by adding buttons and menu items. All of this is available in C++. It's also available in scripting languages such as Python and Lua. I'll have an example of a Lua script later on in the presentation. Alright, so in the next slide we have a bird's eye view of Rewise and the flows of communication between different systems. So in the diagram you see Rewise gets loaded into Reaper. It communicates with your Reaper session through functions available in ReaScript, and then it communicates with your Wise project through WAAPI. Alright, so Realwise is a C++ extension. There are multiple reasons we're using C++. Firstly, C++ is the language of expertise at Audiokinetic. Secondly, we wanted to reuse some code, mainly the WAAPI C++ client. And thirdly, we wanted to minimize runtime dependencies. Okay, so what makes a C++ extension? What are the rules we kind of need to follow? So number one, the resulting binary needs to be a dynamic library. Number two, we need to follow Reaper's file naming convention for extensions. That just means that the resulting binary's file name needs to be prefixed with Reaper _. And number three, we need to implement in our code the extension entry point. The extension entry point is what is the first function that gets called when Reaper loads your DLL. In the extension entry point, we initialize certain objects. We also register callbacks and hooks into Reaper. All right, so let's jump into the Rewise code base. We'll start off with the project structure. Let's look at a folder called third. This folder contains all of the third-party libraries we use in the code. The main third-party library in use is Juce. It may have been obvious when you saw the user interface during Bernard's demo. There's a lot of unaltered Juice components, so it might have been obvious that we're using Juice. The second third-party dependency is the Reaper SDK itself. This contains all the function headers for ReaScript. Then we're using catch2 and trompe-l'oeil for testing and mocking. And last but not least, AK Autobahn, which is the WAAPI C++ client. Before continuing any further, I'm going to mention we're using CMake for build configuration. So the following 4 folders are actually also CMake projects. So let's start off with the extension folder. This contains all of the Reaper specific code. Things like the extension entry point are defined there. There's also code that does all the required calls to the ReaScript API. The second folder is called Shared. This contains all of the GUI components and the core elements and business logic. There is absolutely no Reaper specific code in here. We purposely keep the Reaper part of the application separate to allow Realwise to be more easily ported to another DAW or audio application if the opportunity presented itself. Unfortunately, at this point, none of the major DAWs offer the extensibility required for a port of ReaWwise. The next folder is called Standalone. The project in here contains code to launch ReaWwise as a standalone application. It's mainly used for GUI development and testing. There's no connection to Reaper. All of the data that would be expected from Reaper is mocked. We also wanted to provide an example of Rewise in a context other than Reaper. This diagram kind of shows what I'm talking about when I talk about the separation between the shared part of the code and Reaper, for example. This separation happens with the use of the DAW context interface. So the shared portion of the code doesn't necessarily know what context it's interacting. Everything happens through this DAW context interface. So for that standalone project, we have something called a stub context, which just returns static data when needed from the context that the application is in. And last but not least, we have the test project. This contains all of the unit tests related to the extension. Okay, so in the next section of the presentation, I'd like to show you guys some code. We'll start off with a snippet here about getting Juce to work inside of Reaper. So in the slide, you see a function called onHook command. This function actually gets registered as a callback into Reaper's menu system in the extension entry point. In this function, we check to see if it was in fact our menu item, so the Rewise menu item in the Reaper extension. We check if that item was clicked. If it was, we initialize the Juce GUI system. We create our extension window. We add the extension window to the desktop, and then we set the extension window's visibility to true. The extension window has a main component in it, and from that point on, it's just a collection of Juce components and business logic, just like any regular Juce application. So the next part of the application I'd like to focus on is the preview panel and the code that powers this. Just a little recap, the preview panel basically shows the user a preview of what would be transferred into Wise. So basically the Wise object structures and the associated audio files that would be transferred into Wise. This component pulls information from Reaper. It takes in information from the Rewise GUI, and it also pulls in some information from Wise to produce this preview. So we'll start off by talking a little bit about the GUI, because it's not a vanilla Juce component, although it comprises of several vanilla Juce components. So the first vanilla Juce component here is the Juce table header. Underneath it, we have the Juce tree view, and then we have custom tree view items for each element in this tree view. This custom tree view item actually paints itself as a table row, so we kind of get this tree view that's constrained by the table. You can move and resize columns, and that'll affect the underlying tree view. All right, so let's look at some code. The main class that powers this preview panel is the DAW watcher. It implements a Juce timer. It checks to see if anything in Reaper has changed at a time interval through the DAW context. If something changes, we trigger an update. The update fetches information from Reaper. It basically queries Reaper to see what items will be rendered if we trigger a render, and it basically builds a Juce value tree representation of the object structures defined in the Wise structures GUI component in Realwise. It also then fetches information from the WAAPI from the WAAPI client about the existence of certain objects. We want to know if they'll be newly created or if we're going to replace them. That's added to the value tree. And once we finish constructing this value tree, we compare it with the previously existing one, and if it's different, we swap them. The preview panel is actually listening to changes in this value tree, and when it changes, the preview panel will get a notification and it'll update itself. So in the DAW watcher, we're accessing Reaper through the interface DAW context. We saw a diagram earlier about how DAW context is really what allows us to kind of not be fully concerned of Reaper, or in the standalone version of the application, that stub context. So theoretically, if you can create an implementation of this class for another DAW or audio application, you'd be able to create a port of Rewise for that application. So DAW context gives us access to knowing if the session changed, if anything was updated in the Reaper session. It also gives us the ability to save state and retrieve state. It allows us to trigger a render and so on and so forth. The last bit of code I want to show you is the WAAPI client. The WAAPI client inside of Rewise is actually a layer on top of the existing C++ client. That's because we have a lot of extra business logic to be done before making calls to the existing C++ WAAPI client. So in this example, we have a function called getObject. It takes in an object path. It creates a request for WAAPI. It's basically a JSON structure. It makes the call to WAAPI, and then there's code to extract the result and return it to the caller. So we're approaching the end of the presentation. We saw how WAAPI makes Wise extensible, how ReaScript makes Reaper extensible, and how everything could be combined together to do something special like we saw in ReaWwise. But can we leverage ReaWwise inside of Reaper to provide even more opportunities for extensibility? Could ReaWwise be the foundation for other tools? The answer to this is yes. Reaper allows us to actually register our own functions into the ReaScript API. We do this at startup. For example, ReaWwise fully exposes all of our WAAPI functions to ReaScript. This means that users can build their own C++, Lua, and/or Python extensions using these functions as a dependency. So we're going to go to a live demo to show how this works. Okay, here we have Reaper open. We're going to go to the Lua editor by hitting Actions, Show Action List. We're going to edit a script called getSelectedObjects. So this opens the Lua editor. And here we can already see the WAAPI related functions. So this object here, denoted as Reaper, this is the actual ReaScript API. All the functions are exposed through this global Reaper object. So the first thing we do is connect to WAAPI. We assemble a WAAPI request. Then we make a call to WAAPI. So you see here we are trying to fetch the currently selected object in WAAPI. And then we kind of go through the response and pull out the result. So if we click, if we look at the Wise application here, we see this pneumatic fast large 3 object being selected. So we're going to run this Lua script, and it's a little hard to see, but we have the path to the object that was selected in Wise. We can click on a different object, run the script again, and we see we have the selected object. And that's it. Here's an example of a script that was written that uses our WAAPI, the WAAPI functionality that's exposed to ReaWwise. So I'll leave it at that. I hope you've enjoyed our presentation. Extensibility is exciting, and I hope we've convinced you of that today. I hope we've inspired you to make your tools extensible, as this acts as the foundation for connecting different audio tools together, as we saw in ReaWwise today. On this last slide, we have links to ReaWwise on GitHub. The code is open source, so take it, break it, make it your own. There's also a link to WAAPI and a link to ReaScript and more information about its API. Thank you and have a good day.
Gabriel is asking about Realwise and if it's possible to create a structure, a setup in Realwise first, import the structure to Wise from Realwise, and finally tweak things in Wise in the structure, and then re-import again from Realwise with new WAV files. So the answer is yes, and it's really part of the iteration process that our users have, is to iterate a lot of times from Reaper to Wise and tweak things in Reaper, add effects, change volume, mix differently, and re-import to Wise. And every time they import, if the structure was already created, Realwise will just reuse the same objects. And also if the if anything was added to the Wise project, like RTPC states, make sure that they're not destroyed. And maybe I can add something also. It's about a new feature in 22.1. It's called the paste property, and Realwise also benefit from this. So it's possible to create a template in Wise, for example, a template for a random container. And then in Realwise, specify this template in the structure definition. So every time a random container is created from Realwise, it would take this template as a start instead of creating a one from fresh. So the template could have states and RTPCs, for example, and then this could be used across your Reaper projects, for example. If that answers the question.
Thank you, Bernard. We do have a question, a couple questions here in the room, so I'll pass the mic around.
Hi, great talk, thank you. Did you provide any extensibility to Rewise for like other DAW contexts? Like, say, I'm not suggesting that we make our own DAW, but there might be other, sound generating programs that you might be able to extend and provide a DAW context to Rewise for. Is that something you've thought of, or making it, more than just Rewise?
I can answer that one. So it was definitely designed with that in mind, in the sense where we really tried to separate the Reaper part and only access it through an interface. So technically, if your audio software or other audio software, if you can write extensions in C++ for it, you just gotta just implement that interface basically. In the GUIs, it would be the same, and it would access information from the context it's in through that interface. So we try to make that interface as generic as possible. For sure, every DAW or every audio application will be slightly different, so to be seen if it's going to work perfectly. But we tried as much as possible to design it in that way that it could be ported if you implement that small subset of functionality.
It looks like we have a question from David Weaver online, if you want to take that one.
Yes. So the question is asking about WAAPI in general. So is the idea to establish some kind of agreed upon structure for a WISE project, or should it be on individual programmers to build tools that specifically cater their own or the studio workflow? So it's not so. Importing audio file is one of the strength of WAAPI. It has a extensive API to import files, and that's what Realwise is using mostly. Realwise is importing files and creating wise structures, but WAAPI is not limited to that, and we have seen multiple of our customers using WAAPI to integrate into their own tools. So not only to import audio file, but also to integrate with the game engine mostly. So the game engine is aware of what are the game objects, for example, what things should be available in the game, and the game engine is able to connect WAAPI events, Wise events, Wise sound banks, for example, into the game engine to further optimize the whole workflow. So it's really so we're using it internally for our Unreal and Unity integrations, but we have seen many customers using it for a variety of different things.
I can add something there. So like Rewise, like when we build a tool, like for example, Rewise, we try to like build something for like the common denominator, I guess. So like we try to make it as generic as possible. So Rewise allows you to really define the structure of how what you want to create in Wise, or how you're going to import stuff. So, you know, one game studio versus another one might have a different way of structuring things. So we try to make Rewise as flexible as possible to try to fit any type of that kind of use case. And then bigger game studios might invest the time and build their own thing if they have a really, really custom way of doing things.
There's a follow-up question about the first question from Gabriel. He asked about creating structure from Rewise and doing it multiple times. So the question is, can track volumes from Reaper be carried over to Wise? So sound designer can mix in Reaper basically. Andrew, Reaper track volumes, are they exposed through wildcards?
Good question. I don't have the answer to that. I wouldn't be surprised if it would be though.
So, yeah, so the answer is probably, maybe not. We'll have to investigate.
I just wanted to quickly ask about the adoption rate for ReaWwise for gaming studios. How are you finding there's a surprising amount of game studios adopting this, and are there any challenges in getting teams to adopt it more often?
I don't think we know, actually. It's pretty new. ReaWwise was released September. We have some, it's freely available from GitHub at the moment and from ReaPack. So we don't have much tracking on how many people are using it. So, but we would like to be, would like to know about it. So if any one of you has tried it, we want to hear about it and we want to improve it over the next years.
Any more questions in the room? No, I think that's all we have over here, Andrew and Bernard. Thank you so much for the talk.
Thank you.
Thank you.
Have a good day.